Good morning to one and all present over here. It's my pleasure to welcome you all to this webinar. I am more than grateful to stand here and welcome you all on lecture series, online webinar on an overview of cloud application, systems, components, fundamentals, organized by eInfochip, an Aero company, and IESA, India Electronics and Semiconductor Association, Gujarat chapter. On behalf of the organization, I would like to welcome you all and inform you that the webinar will completely enlighten your pertaining to the cloud. All the vital aspects regarding to the topic will be conveyed to you all. I kindly welcome our today expert, Dr. Chirag S. Thaker. Dr. Chirag S. Thaker is a professor and head Department of Computer Engineering, LD College of Engineering, Ahmedabad. He has an experience of more than 24 years in the field of teaching and research. He obtained his BE degree from DDIT Institute Nadiad in 1997 and ME degree in 2005 in the field of computer engineering. Dr. Chirag Thaker obtained his PhD from Suresh Gnan Vihar University, Jaipur, Rajasthan in 2013. He is presently an associate dean and mentor for NAC/NBA accreditation at Gujarat Technological University. He has published more than 50 research papers in international referred journal and conference proceeding for the area of computer science and engineering. He has guided PG dissertation and doctoral scholar. Dr. Thaker reviewed book in the field of computer science and information technology. He was a recipient of National Education Alliance for Technology Certificate of Appreciation as a nominated member of an independent expert committee for evaluating the solution course of NEET 2.0 from AICTE and certificate for exceptional contribution as primary evaluator in Toykathon 2021 from AICTE. Without wasting much time, I hand over to Chirag Thaker, sir.
Thank you. Thank you, sir, for your generous introduction. I hope I'm worthy to that. Uh, Namaskar. Good morning, all. It's been great pleasure to be associated with eInfochip. Uh, Thank you, the top management, for inviting me for this session. And I also thank the office bearers of Indian Electronic Semiconductor Association for creating this platform through which uh, we become torch bearers so far as the field of electronics, VLSI design and ICT systems are concerned. It's always been a pleasure to interact with very young and dynamic staff of eInfochip whenever I visit their campus. Let me start the session, which is titled Cloud Fundamentals, History, Services and Application. This is my first presentation, and this is going to be the flow of presentation. Friends, we would be talking about computer evolution, rather revolution, because as a branch of computer, it has not only changed the way we used to operate the world, it has also changed our very basic notion of human existence and industrial revolution. Then a couple of slides on digitization to digitalization, and then I'll formally enter my subject in cloud computing, where we have 4 to 5 different definitions of cloud and cloud computing, and then couple of slides on cloud features. And then we will take a very systematic long view of the history, how history actually unfolded the branch role cloud computing. And this new technology paradigm has taken over the entire world. There are certain concerns about cloud also. So some slides on clouds and cloud concern. And then we'll also try to touch upon the brighter side of cloud computing. And then in the last leg of this presentation, we would be discussing about the cloud and consumer services, and then some selected slides on Google Cloud Apps, and then the technology which actually drives the entire revolution of cloud computing is called virtualization. So with this, let me start this I call acknowledgement slide. It is like the disclaimer kind of slide. Here, the presentation acknowledges the content and images that are taken from book titled The Complete Cloud Computing Manual. Also note that the images are mostly Google images with universal image URLs as www.images.google.com. So here because some of them are under Creative Commons license, some of them are not. So I here declare that the images and the content are used purely for an academic purpose or training or content delivery purpose. As a presenter, I do not have any intention of copyright infringement. With this declaration, let me start the slide with one of the finest quote from one of the finest researchers, scientists the world has ever produced, Mr. Albert Einstein. He said, we can't solve problems by using the same kind of thinking we used when we created them. So in very early primitive years of scientific revolution, which actually he kick-started, he said we need to have the out-of-box thinking. And here I would also like to quote Mr. Satya Nadella, who says our industry do not respect tradition, our industry respects innovation. So with this quote, let me go to the second slide from one of the computer geniuses who has given us one of the finest products of our times, Mr. Steve Jobs. He said innovation is the ability to see change as an opportunity, not a threat. So when we say research and innovation, when we say product development, for us, innovation is definitely an ability to see the change. It's an opportunity. It definitely comes with technological challenges, but this opportunity is a very big milestone. In front of you, this slide is dedicated to the generation of computers. And here you can see very well that we have started with first generation of computer devices, which lasted almost 13-14 years, where it was a very smooth transition from the valves to transistors. And the size of these first generation computers were very large, huge amount of power consumption, and a lot of manpower actually went into building them. But then we started the era of miniaturization. And in that miniaturization, we started reducing the size as the progressive journey of LSI to MSI, that is medium scale integration, and then VLSI. And that's why second generation to third generation, we could visualize that the entire computer system, which was very large or huge in size, has become the desktop system. So as Henry Ford said that I want to park one car in the courtyard of every American household, this is also being the dream of the initial founding fathers and companies like IBM and Mr. Bill Gates, that they just wanted to keep a computer system on every desktop. And that's why personal computer, when initially they were launched, they were called desktop systems. And this desktop system evolution, or rather evolution, continued in the fourth generation also. And then came the Pentium revolution, and the miniaturization actually continued. So if you very carefully observe the progressive idea of the entire generation, this fifth generation, which is still being continued, has really reduced not only the size of this, but it has strictly followed the Moore's law, and the handheld devices has actually come into existence with more computing power than any of the server capability of 80s or 90s. But once we focus on these pictures, we have to understand logically behind these pictures what is the journey. If you want to understand that journey, let us try to understand the this entire era from mainframe systems to connected world. And if you look at this slide very carefully, you can see that mainframes were dominating the world later part of 60s and entire 70s. And then 80s and early 90s came the PC era, the desktop era, in which we started putting them on our desk. But that was not the end of the story. It was rather the beginning of the journey. We started connecting them, and this network revolution started. And the best part is we fortunately progressed from local area network to metropolitan area network to the our basic understanding of wide area network. And we entered into the era which is one of the finest magical computer networking era, which we call internet. And once internet was there, after internet, the proliferation of social networking this sites has actually made or rather converted the entire consumer community to the contributor community. Let me elaborate here. See, when the internet got started, the initial days of World Wide Web, the initial days of HTTP and HTML were having a very limited understanding of a very few people, maybe 10-15% people used to were content creators. They used to create static or early phase of dynamic websites, web pages, and they used to put content. And the entire consumers were just downloading that content, 85 to 90% of the people. But proliferation of social networking site, reach internet applications, and this website and web service journey has transformed this conventional user into consumer. And when the conventional user got converted into consumer, they actually started using this Web 2.0 revolution, which was supported by HTML5 and all other development like service oriented architecture and related technological paradigm. And that's why 2000, the entire decade of 2000 is dominated by the social networking sites. And here we mark the new revolution. And this new revolution is also continued. And now we have entered the era which we'll call connected world. And this connected world has many technology. It's like mushrooming of the web services and web portals. It's more of connecting every single object which can be connected should be connected. So that is the mandate of any IoT application, that any device, any object which has the digital interface should get connected. So variables, IoT, and then what we have is the entire ecosystem, which we call smart home, smart car, smart city, and all this. So connected world. Here, cloud has a very definitive impact onto this. Cloud technology is a mature technology now. Now, any technology, when I say mature technology, any technology can be called mature technology only when that technology is an enabler technology for others to prosper. You take blockchain, you take IoT, big data, data analytics, data science, cyber security, cloud. You cannot imagine this technology prospering without having the cloud setup, without having the cloud implementation or cloud technology. And that is why I call cloud computing enabler technology. And that's why we are discussing this entire journey. Now, to create verticals of this slide, let us move to the next slide. Friends, here you can see mainframes. They were in the range of 1000 to 10,000 devices and 50s to 70s. And the users of these mainframe systems, they were called digital refugees. And they were greatest generation and silent generation. Now, why do I call them greatest generations? Whether it is Dennis Ritchie or Cunningham or any person who was working in this era, actually they had no reference point. Whatever they have created, it's almost like invention kind of stuff. And because of them, we call them silent generation or greatest generation. But when we enter the personal computers, and so far approximately 1 billion devices are sold, and it is almost like 2 decades, 80s and 90s. And this generation we call digital immigrants. And these digital immigrants, we also call them baby boomers or Generation X. Now, why they are digital immigrants? Because their entire setup, process and practices, they have switched from the analog world, the analog era, the conventional setup, the conventional processes to digital processes. And that's why we call them digital immigrants. The next is mobile cloud. And this mobile cloud, the entire decade is like 2.5 billion plus devices. And these numbers are exponentially increasing. And now we call this generation millennials or Generation Z. They are digital natives. Why? Because their initial childhood thinking is menu driven. For them, icons means business. For them, icons or applications means their existence. And that's why these millennials are very much inclined towards using the way this digital world actually takes the shape. And now after 2020, we have entered a world called metaverse, where hundreds of billions of devices would be used. And this entire metaverse era or meta universe era would be marking one specific phenomena, and it is nothing but the physical and digital convergence, and the generation would be called Generation Alpha. So once initial thoughts on the entire journey of initial days of computing revolution to metaverse, let us now enter the 3 stages of digital transformation. We started our basic understanding of digital world through digitization. Now, what is digitization? It is fixing the past. What is digitalization? Focusing on the present, the practices, the processes, the procedures. Digital transformation, creating the future. So these are not simple words. Let us try to understand their meaning. So digitization is nothing. It is process of transitioning from analog to digital. So if I have something on piece of paper or I have some processes as per the menu driven charts, I am just converting them into digital entities. That is digitization. What is digitalization? It is the process of making digitized data work for the business. So if my data is not making any value addition to my business processes, that data I need to convert or rather transform so that it makes business sense. If my processes or my procedures are not mapping or matching with my digital existence, my digital uh, uh, processes, then I have to make that transition. And that will lead me to digital transformation. So once I implement digitalization in one of the finest way, I can achieve digital transformation. And it is nothing but application of digitalization to transform business. And that's where, like when somebody says digital marketing, I take it as the baby step of digital transformation. Even if you are a sabji vendor, even if you are only selling pharmaceutical products, if you do not have e-market presence or web presence, you cannot make your business prosper. You need to have your digital footprint, and to increase that, I have to enter this digital transformation era. And once we understand them, we just say that digitization is nothing, it is convergence. Digitalization is adoption, how you adaptability. And digital transformation is creating from scratch. It is like creating or value-based business creation from scratch. It's called digital transformation. Now, once we understood this initial slides, let me formally enter the subject which we called cloud computing. And initial slides are on the definition of cloud computing. This is one very famous from NIST, that is National Institute of Standards and Technology, US Department of Commerce. It says cloud is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. And when I say resources, it includes networks, server, storage, applications, and services that can be rapidly provisioned and released. So here the word is dynamic provisioning, and we have a couple of dedicated slides to understand dynamic provisioning. With minimal management effort or service provider interaction. So this cloud model promotes availability and is composed of 5 essential characteristics, 3 service models and 4 deployment models. Friends, these 3 service models and 4 deployment models we would be discussing tomorrow, but in this we'll definitely discuss all the essential characteristics in this presentation only. This is a Wikipedia definition which talks about internet-based computing, and it also talks about style of computing in which dynamically scalable and sometimes uh, often virtualized resources are provided as a service. So this is a very big uh, transfer or transition where the computing resources are now as good as utility services. What are the other examples of utility services? Electricity, water, piped gas, they are utility services. You have not visited where they are produced. You do not know how to make them, but you are using them day in and day out. And this is the biggest achievement of the entire computer fraternity, that they have actually made so much progress that in the span of 50 years, they have actually transformed the computing capability. And when I say computing capability, I mean by servers, storage, and network. 3 major verticals. So they have transformed this entire computing capability into utility services. And so you are no longer the product users, you are rather the consumers of computing capability. And when you are consumers, the computing capability is given to you in form of services. And that is the main idea, that is the main achievement, and that is the main objective of having this entire new paradigm or model called cloud computing. And to cater to that, what we do is we create virtualized resources. If we just go to another definition, it is said that why do we use this cloud symbol? So friends, in telecommunication network, what we used to have is in system diagrams, when we used to showcase the network part, earlier days, we used to use this cloud symbol. And then the biggest and the most successful network phenomena, that is internet. So whenever we wanted to represent the internet in flowcharts and diagrams, we used to use this cloud symbol. Now here, cloud computing is a general term for anything that involves delivering hosted services over the internet. So let me specify here that you use that cloud symbol to actually showcase ubiquity. So ubiquitous is the word. Now what is ubiquitous? The dictionary meaning of ubiquitous is universally spreaded. Friends, there are two technological domains, or rather paradigms, models, which are ubiquitous in nature. One obviously is internet. Second is telecommunication network. So cloud computing, the biggest asset to associated with cloud, or you can map to cloud, is nothing but its ubiquitous nature. It is universally spreaded, and that is why we use this symbol uh, uh, to showcase or denote cloud computing. This is from Berkeley cloud definition. We already visited 3 to 4, so I'm not going to explain this, but here there are two things which we need to highlight. The cloud refers two things. One, applications delivered as services over the internet. So that is number one. And number two, hardware and software, or hardware and system software, that is in data centers that provides those services. So there are two things: applications which are delivered as services over this, and hardware and software which is in data center that provide those services. Now, once you understand that, you have to understand that because cloud is a utility service, cloud is made available in a pay as you go manner. If I consume more electricity, my light bill or my energy bill would be higher. Likewise, if I consume more servers, if I consume more storage or networking devices, definitely as a company or as an individual or as an entity, I'm going to pay more. So that is main idea, that we provide this cloud as a utility computing. So once we understand, this is a very famous definition from one of the prominent academician researcher in cloud computing called Rajkumar Bhuiya. And Rajkumar Bhuiya actually gives a little bit more technological definition. So let us just read the definition as it is stated on the slide. It's a type of parallel and distributed system consisting of collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources. And it is based on service level agreement between service provider or cloud service provider and cloud consumer. So here in this entire definition, he talks many technical jargons. He said, virtualized computers, dynamic provisioning, unified computing, resource pool, service level agreements, cloud providers or service providers, and service consumers. So this definition is very techno-rich definition. But if we just put this entire definition and its basic understanding into small keywords, it gives us features of cloud computing. So let us take the first one, resource pooling. So basically all the available resources, they are pooled together. And this is not the first experiment with resource pooling. We have already seen as a computer engineers or ICT fraternity people, we have seen earlier attempts also, like cluster computing or clusters, grid computing. So these are the anecdotes which you can connect with resource pooling. So here the main word is one is all and all is one. Let me explain this phrase. One is all. One big machine having all capability. And all is one. All these systems, whether they are storage devices, whether they are servers, networking part, and hierarchy of memory systems, all when I put them together, they are one. And that is nothing but putting them together and then creating this abstraction level. And through this abstraction level, we treat them as one big resource. And that abstraction level is nothing but it is achieved through virtualization. So basically, all these physical devices may be at one place or geographically dispersed place, but they are treated as one big resource pool, and that is called resource pooling. Now, once you understood the first feature, on-demand self-service. As demand, it shoots up, it shoots down. There's a company, it's a Japanese company, I forgot the name. It actually converts your photographs and your video clips into full-fledged video. And when they adopted actually cloud computing, In the first week, they jumped from using 70 servers to 5,000 servers. That is on-demand self-service. I just skip the name as it will come to my mind. I'll share with the audience. So that 70 servers to 5,000 server, that jump, it's demanding. So scaling up, scaling down. So that is scalability, and that scalability is on demand and pay as you go model. Third feature is easy maintenance. As a company, as an individual, as an entity, you are not making any upfront investment in procuring systems, servers, staff, any kind of software licenses. Basically, you just put to the cloud service provider as per your demand, and it's very easy maintenance. Large network access, and we will see this network access and capability because ubiquitous nature of cloud computing ensures that the entire services, whether it is platform as a service or infrastructure as a service, is very handy and it is available 24/7, uninterrupted, seamless access. And that is availability 24/7. Automatic system. You don't have to bother for patches, upgrades. You don't have to bother for how to maintain them, hiring very high-end technical staff. Only thing you need is a subscription kind of model where you can access or utilize this automatic system. It is very economical. Uh, some of the studies says when you switch to Amazon Web Services, AWS, and different products of Amazon, uh, you can make like savings like 20%, 25% of the cost than the having the in-house resources. Security, yes, there are security benefits also, and there are security concerns also. Pay as you go model, we already discussed. And as a company, if I'm a cloud service provider, every single resource in my data center is not as cloud resource. There are certain resources in my data centers and certain applications I create as a cloud service provider, which I call monitoring and control. And this monitoring and control is nothing but actually it supports cloud computing as a measured service. And once I have measured service, I can control and I can also charge accordingly, and I can ensure the availability part, the scalability part. And that's why measured service is a very big term, because if I want to achieve scalability, availability, and pay as you go model, I need to have a very robust kind of measured service setup implemented in my premises as a cloud service provider. The same features, I'm not going to repeat them. The only thing I want to uh, make you aware is this large network access economy is because it is economy of scale. And here you will agree with me that the major cloud service providers, whether it is AWS, whether it is Microsoft Azure platform, Google App Engine, or any kind of SaaS, Force.com, Salesforce.com, they all actually operate because of the benefit they are getting through economies of scale. And these economies of scale and this time zone, global time zone actually helps them to provide the best of the on-demand self-service or resource pooling or easy maintenance. And these economies of scale is the factor which actually triggers the $1 trillion cloud success economy. Friends, on this slide, it is nothing but repetition. Pay as you go, we already discussed. Ubiquity, we have already discussed. One specific picture which says cloud storage. And here you can see that whether it is Amazon, whether it is Dropbox, whether it is iCloud, it is nothing but the success story of cloud storage. Google Drives, cloud storage. Why? The reason being is you have many documents, files, videos, pictures, which you want to store on cloud. and you need seamless access. And that's where cloud storage actually comes into picture. So cloud storage is a very big success story, and behind the entire success of cloud computing as a technology paradigm. Security and disaster assistance will definitely discuss. Lower cost of ownership. Now here I would like, I already given you a word of front investment. So capital expenditure and operational expenditure. It's a very big journey of shifting from capex to opex. Because if you want these servers, the storage, the softwares in your company, the cost is going to be very high. And that we call capital expenditure. And then obviously you have to also, as a non-IT company or IT company, the capital expenditure definitely brings portions of operational expenditure, where maintenance, patches, IT staff, their payment, database administrator, and all this actually comes. But when you adopt cloud platform or cloud services, you actually subscribe for, this lower cost of ownership actually comes, and it's more of the subscription based model. And the companies which are actually making this giant investment, like Amazon, Google, uh, Microsoft, or Apple, for them it is economies of scale, and that's why it is affordable to them also. So cloud on both the slides, cloud service providers and cloud service consumers. The lower cost of ownership is because of economies of scale. The lower cost of ownership is because of the transformation from capex to major part of operational expenditure. Here, I do not want to say that there is no capex. In fact, all these giants actually makes billions of dollars of investment. But here we need to understand that if I have, let us take one example. I just give you one very trivial example. Let us assume that there are 25 people working in a company. And even if they are heavy duty graphic developer or animators, and I give them 25 high-end laptops for their development work. Here also, in that case also, if their average is like i5 or i7 processor, even if they are graphic developer, heavy duty programmers, or they are animators, they hardly use more than 60% of the processing power. If I remove the redundant storage, they hardly use 55 to 70% of their storage capability, including the RAM, because RAM sometimes shoots up 65-70%, but even in that case also 20 to 25%, 30% of their RAM capability is not used. Same is with the connection, the power, and all this. Hard drive, if I remove the redundant files, it is almost 20-30% of their storage is not used. Sometimes that is 40%. Now, this is the example of 25 people who are high-end developers or animators or graphic developers. Friends, think about normal developers or people who are doing data crunching operation. In that case, 40 to 55% of their computing power, storage is not used. And if 5 new people join my company or organization, I will also think about procuring 5 new laptops. That means I am not utilizing the existential computing power, the storage, but I am actually using, I am procuring new one, and that is my IT investment. So if you are the chief technology officer of a company and you are making $2 billion of IT infrastructure investment every year, in that case, the situation is not acceptable. And that's why shifting to cloud actually lower the cost of ownership, because from 40 to 55% in normal case, and in specific case 25 to 40% of the IT resources are underutilized or non-utilized. And this underutilization, if I were to come out of that trap, I call it trap, then it is nothing but shifting to cloud. Because that's where through virtualization, we actually harness the capability of my processing power. We harness the storage capability, and we also harness the capability of my networking resources. And that is why shifting from normal setup, in-house setup to cloud setup actually lower the cost of ownership. And that's where my operational expenditure comes. And that's why I said the situation is not acceptable if my 40% of resources are underutilized or unutilized. And that's why I have to adapt this. If we come to automatic and easily upgradation, software updates are available, and there is a couple of slides dedicated to this. So we'll visit them. Now, this cloud is an enabler technology. It is enabling the entire revolution of big data, data analytics. I already explained blockchain and all this. You cannot imagine your existence without using any of the cloud applications or services. So it's a journey from cumulus to cirrus. What is cumulus? It is an English word which says thick cloud. And what is cirrus? It's high altitude light cloud. And that's why what I am trying to give you is the concept to daily use, and the entire journey of conceptualizing cloud kind of availability started 50, 70 years before. It started in 1950s. So the entire journey of this cloud has a very profound historical milestones. And this part of presentation will discuss those historical milestones. So 1955, and the gentleman which is here is John McCarthy. Now John McCarthy is famous for his Dartmouth conference. It's on sideline talk, but let me brief you here that Mr. McCarthy and researchers of that era actually created one revolution. It's called Dartmouth Conference. You can Google it. And in that conference, they actually set for one, it was in Dartmouth College, and they spent 25, 30 odd researchers actually sat there, and they visualized the idea called intelligent machines. And this gentleman is responsible to give that word artificial intelligence. And this man actually is also responsible for Lisp programming language development. He is also responsible to set up MIT AI lab. So man of this stature, there is a popular myth, and the myth says he actually coined that, he actually dreamed up the concept of computing time sharing, because in those days computing costs were very high, and very high-end industries has to reserve 1 hour slot to use the mainframes, and they used to give handsome amount of money for that batch processing task or computing task. So McCarthy came up with the idea that can we have the later part of development where we can rent the time shared computing resources to companies who couldn't afford the technology. And there are many researchers and developers in this industry who regard this idea as the beginning of the cloud concept. And friends, to your surprise, do you know from where this thought actually came to struck his mind? He was fascinated by the idea called the telephone booths. So American cities used to have this line of telephone booths. So he said, can we have this kind of setup where these time sharing computing resources can be given to companies? So 1955. Then after 1972, and this is the first Hercules emulator program, and it was launched by none other than IBM. So they developed their mainframe system called VM370, and it is called Virtual Machine Facility 370. And when they created this system in 72, they used this Hercules emulator program. And through this program, scientists of that era, they were able to access the VM370 in multiple virtual machine states from a single system. And this is way back in 72. where we started this virtual machine. And now we have very many products which gives us this virtual machine uh, uh, in totality. I can say hardware virtualization, system level virtualization or virtual machines, program virtual machines, which is used for past development. But the journey, if you connect the dot backward, the journey actually started in 72, the actual implementation of virtual machine concept. 1969, 3 years before, JCR leader who developed ARPANET. Now there is a very tricky story behind ARPANET. Actually, they procure all these resources because the World War was there in 40s. So later part of 40s, they actually hired, they actually invested millions of this rupees to procure the resources. Now, when the world was over, what to do with the resources? So they said, can we use this to set up a network? And through this network, can we have these computing resources, the capabilities and the capacity building in the form of ARPANET to the university campuses? So it was a very novel idea of establishing the initial days of internet, because ARPANET is a network that eventually transformed into internet. And his vision was for everyone on the globe to be interconnected and accessing programs and data at any site from anywhere. And this man is responsible to provide that huge sums of computing infrastructure and resources to university campuses through this ARPANET. And actually that actually brought a lot of wisdom and research foundations in the field of computer technology. And the beneficiaries, if I just name them, MIT, Stanford, University of California, Berkeley, they all got benefited from this ARPANET network. And the rest, as people say, is history. Here, throughout the 80s, the home computer boom was there, and there were improved communication technology. And people started using this 300 bits per second modem. Now, when they started doing all this, internet was on one part standardized. And there was a very good success story of MS-DOS, Novell and other companies. Now, all this, when we put them together, actually it's a secret source. And this secret source gives us resources which are housed on servers elsewhere in the world, and it became accessible to bulletin boards and features or programs like this. And this marks the base of this modern day cloud computing. This is a picture of a confidential presentation. It's called CST presentation from Compact Executives, and it's called Internet Solutions Division Strategy for Cloud Computing. And it is in 90s. So actually they made these presentations and they actually used the word for the first time called cloud computing. And who used them? Compact computer engineers. And in 96, they made this presentation called Internet Solutions Division Strategy for Cloud Computing. And actually in this presentation, they also showcased their vision for the company's future business model in cloud computing. In 1999, the cloud computing concept got started in its true sense with the earnest launch of Salesforce.com. And Salesforce were actually using the maturing internet technology to offer shared sales information for a company. There are many companies who are doing this sales and marketing, and they offered them initial version of the solution. And they use this maturing internet technology, and they highlighted collaboration, storage, and reporting through web-based portal. And actually this initiative made the way for other companies to adopt cloud and to deliver applications and enhance content over the internet. It was 1992. Now, before we go to 2002 AWS launch. This slide is 2006 to 2012, in which Google had its own growth and domination of the internet. And that's why Google was a household branch and company, and everybody was using their search engine. So they had their own presence in this entire digital world. And they use it to release Google Apps cloud-based services in 2006. In 2011, Apple also joined this journey, and they announced its own cloud storage solution called Apple iCloud. In 2012, Google Drive was launched, bringing together all the cloud definitions under a single service. So this has been a remarkable year, 2006 to 2012. But before that, 2002, Amazon as a company had certain servers lying idle. And it's a story. And there's one executive approached 3 to 4 company other technical staff, and they made a proposal, and their boss accepted, and that's how AWS was launched. So it's a significant milestone in the history of cloud and cloud services when they launched the AWS, Amazon Web Service. The service provided a cloud-based suite of resources that ticked every aspect of cloud definition. It offered storage, computation, and most important, virtualization. And it was quickly expanded. The company not only made billions of dollars after the immediate success of AWS, and then they launched many products like EC2, Elastic Compute Cloud, which is nothing but servers, S3, storage. So there are many products with which Amazon actually entered the market and prospered. But they were, I should say, founding fathers of this computer journey. And that's why they have a very prominent place when we discuss history of cloud computing. Because giving idea in 1955 or creating VM 370 from IBM is equally important to launching AWS or Salesforce.com or Google Drive in 2006, 2002, 2012. And now we are on the last slides of discussing the history. The use of more powerful mobile devices, better networks, and faster access to internet. Because this is the era where, if I say telecommunication wise, 3G, 4G became overnight success. And the entire mobile commerce, mobile economy actually dominated the world. And this has really made this cloud boom, and it's overnight success. And when I say overnight, that lasted almost for 5 years. And if you put the entire investment together, by the end of 2016, the Silicon Valley has made somewhere around $1.4 trillion investment, and they have never looked back. It's really taking the entire digital revolution to a new height, where every single service, every single product is cloud-based. And this cloud-based web service related solutions has actually made the entire success story. Now, once we understood the history, let us try to understand the types of cloud services that we are consuming. But before I move to that, I give you some buzzwords like Google Drive, Dropbox, and all this. And there are many such other products and services. But as I said, before we move to cloud services, there are base technologies like service-oriented architecture, web services, availability of faster processors, very fast processors, availability of rack servers, availability of rack storages. These are nothing but these are the pillars on which the entire cloud service industry is standing. So there are many services, because I always say cloud is a service-based delivery model, and on a lighter side, cloud is a service-based delivery model. But the actual technology that drives the cloud is nothing but virtualization. So when I say service-based delivery model, the number one is, and that's favorite to, it's called GASS, GAAS, Gaming as a Service. It is set to make more foothold in 2020, because this is like the old book. So that's why it talks about 2020, where Google Stadia or Project Cloud is there. And it enables the player to launch any title in company's library and play them using various kinds of devices, whether it is a smartphone, tablet, or PC. The only thing is the person should have the internet connection. And if the GAS works well beyond 2020, the console, the gaming console, could become obsolete. And this is a very big statement. Desktop as a service. Now, this is one specific service or application that enables workers to use their main desktop from any device anywhere in the world. And you think about a company setup which has 15 employees, or 500 employees, or 2000 employees, or 20,000 employees, whether it's an IT company or a non-IT company, whether that company is very much into data processing and data crunching operations, or that company is a manufacturing company where there are divisions like sales, marketing, finance, and all this. But their day in and day out work is nothing but their job title work, and their entire job title related work is there on their desktop, to which they work every day, 24/7, or sometimes 365 days. And what you give them is, you give them desktop virtualization, and they can access either through Windows, Mac, or Linux desktop via the cloud. And they have icons, work, shortcuts, and everything is there on desktop. So it's called desktop as a service. And if you are a potential business person, you can visualize that my employee, he or she, can access his desktop from any location, from any device. And this is one major service cloud can offer. Another one is communication as a service. If I just put them, it is a cloud-based telecoms, messaging, and video conferencing solution. Skype is another remote video calling service, and it is very plug and play. So basically what you are giving them is the entire communication line as a service. And there are many service providers which are offering CaaS. And it sounds complicated, but actually it is a very good way of providing communications. And in the world where right information at right time to right person makes a business sense, because when I give you right information at right time in right context, it gives you a very big business advantage or contextual advantage. In that world, if I give you CaaS, communication as a service, to my n number of employees, that will definitely add a lot of value to my existing business and to my business growth also. And that is why cloud is actually touching upon every sphere of human life. Cloud technology, why more than $5 trillion of investment from all these techno majors, even non-techno majors? The reason is this, that cloud gives you services, and this service driven model actually helps every single individual to consume these services. Let us take the third one, database as a service. It leaves the administration of the company database to cloud service providers, and workers can concentrate on using the database. They don't have to bother about the overhead of DB admin. They don't have to put themselves in the nitty-gritties of how to handle this, how to keep this database active and live. Rather, they have to think about performing data mining, business intelligence decisions on the existing database, which is given on their systems or machines as a service, which we call database as a service. And that's why it is a value addition to any company. Hardware as a service. It is different from other cloud-based solutions, but company can rent all of its hardware from the provider, like printers, computers, phones, tablets, all entire range of hardware devices as a service can be rented and can be consumed also. So it's both way. If you have made strategic investment and if you want to provide them as a device, as a service, you can. You don't want to make investment, but you want to consume them. In that case also. So it's a both way. This hardware as a service coin has both the sides, renting also, consuming also. Identity as a service. It's a cloud-based identity and user management. One simple understanding of giving you identity as a service is like single sign-on, which is implemented very successfully by Google, and now everybody is using that, is nothing but one credentials management. So friends, before I go into identity as a service, let me give you what kind of identity we can manage. So like personal identity, your name, your address, your details, your numbers, your PAN number, your Aadhaar card, that's your physical identity. What about your digital identities, your credentials, your passwords and related stuff? But your digital identities can be mixed with your biological identities, your fingerprint, your iris, behind in your pupil, behind your this eye, there is iris. So your biological identity. So I can use your personal, digital and your biological identities. I can mix them and provide you a solution. DigiLocker is one example. It's a cloud-based implementation and millions of Indians are using it. We all are proud Indians for DigiLocker, and such many services are there. So on one hand, when I say IDaaS, I have example like DigiLocker on one side. I also have the example of single sign-on. So identity is a service, is a cloud-based identity management service. And this is very good because I can integrate thumbprint reader software or iris detection access in IDaaS. Storage as a service. In earlier slides, I've already briefed you that there are many cloud success stories where storage is the centerpiece, whether it is Dropbox, whether it is Google Drive, whether it is iCloud. So storage as a service is where you simply buy cloud-based storage. I always, on a lighter side, tell to my students that any company which has data, any company which has human talent to process that data, and any company which has the algorithms and the processing power to process that data would be the next billion-dollar company. And storage is actually increasing. And I give you one simple example. There is a term called zettabytes. Now, what is a zettabyte? Zettabyte is nothing but it is billion terabytes or trillion gigabytes. I repeat for your understanding. It's billion terabytes or trillion gigabytes. And if I talk about 2002, 2003, from Stone Age to 2002, human race has created less than 2 zettabytes of data if you remove the redundant data. And today, that means Stone Age se leke, from Stone Age till 2002, only 2.5 zettabytes of data human race has created in this entire world. 2009-10, 2 years only, we created 4 zettabytes of data. And 2025 onwards, we would be creating more number of zettabytes of data, petabytes, zettabytes of data in 1 month, which is equivalent to 2 years of that 2010 decade. And when this data is actually increasing, and that's why it is said data is the new oil and AI is the combustion engine, if I'm not making a mistake. So in that case, storage as a service, this is where companies can make millions by providing storage as a service, and companies can save millions of dollars by using this service. Because if you are a data crunching company, or even if you are a manufacturing company, whether you are an FMCG company, huge sums of data is generated. Volume, velocity, veracity, variety, these are various dimensions of data. And 80% of data that you generate today, they are unstructured data. Now, what is structured data? Any data which I can put into rows and columns. The conventional database data, I should say, where creating metadata is very easy, is called structured data. Then there is semi-structured data. Your XML files, your JSON, they are semi-structured data. Then what is unstructured data? That is your likes, dislikes, photographs, video, streaming, the body of an email, the Word document, your presentation, everything is unstructured data. And what is their market share? The digital market share is almost 80 to 85%. And such data is exponentially increasing, not only in terms of petabytes, in terms of zettabytes. And that's why storage as a service is where you simply buy cloud-based storage. And company can make this task for all its workers, and they allow the workers to access this cloud storage as opposed to companies in-house storage. Because as a company, if my data is exponentially increasing, I have to make very high-end strategic investment in buying these storage racks. Instead of that, I can have this Google Drive or Dropbox or any of these solutions, and I have to only pay for increasing storage. I don't have to make this capex or upfront investment to buy these storage devices and related servers to process them. Infrastructure as a service, platform as a service, and software as a service. These are three very major service which we will discuss tomorrow in greater detail with technological lens. Right now, I just do not discuss them. They are nothing but there's a success, there's a pyramid. And if you look at the bottom of the pyramid, it is infrastructure as a service. Above it, it is platform as a service. Above it, it is software as a service. But if you think about customer base, you have to shift the entire pyramid upside down. If investment point of view, infrastructure as a service is the bottom of the pyramid. Then platform as a service, then software as a service. Customer base just upside down. The largest customer base and the revenue model is software as a service, then platform as a service, and then infrastructure as a service. We'll definitely discuss them tomorrow. Right now, I'm just giving you the flavor that software as a service, platform as a service, and infrastructure as a service. When I say infrastructure as a service, there are three major verticals of providing you infrastructure as a service. They are server, or you can call it compute, then storage, and then network resources. Three major verticals in which we operate. When I say platform, it is nothing to develop application. So it is more of integrated development environment. So it provides you that development environment, or I should say software stack to develop applications, to develop services and application and then deploy them. So it's called platform as a service. So this platform helps you to develop softwares using development environments and development platforms. And third one is a software as a service. YouTube, Netflix, Gmail, Google Docs, Salesforce.com. These are very many examples of SaaS success stories. Just software I am giving you as a service. You don't have to bother about a maintenance, patches, upgradations and all this. Anyway, tomorrow we have cloud problems. I should call them cloud concerns. Why? Because it is the responsibility of the entire company fortunes, and there are private data, companies' data at stake. And that's why there are many ideal solutions to any company which clouds can provide, whether it's individual or company. But there are concerns also. And when we look at the nature of the cloud, there are certain concerns which are very easily visible, or you can feel them, and they can reduce your business to a virtual standstill. And what are those concerns? What are those cloud problems or issues that we are discussing? Cloud security is one of them. There are many others. Let us visit them. Upgrades. Now, on one side, when I say if you adopt cloud services, you don't have to bother for maintenance. You don't have to bother for upgrades, automatic upgrades. Your company, your IT staff do not have to bother for all this. So unquestionably, it is beneficial. But automatic upgrades in the cloud has a negative effect also. There's one very typical, peculiar example that I would like to share, that in 2011, Amazon's EC2, now EC2 stands for Elastic Compute Cloud, ECC, EC2. Elastic Compute Cloud suffered a huge outage, or I should say shutdown, as a planned upgrade went horribly wrong. Because this upgrade went wrong, storage went offline. And in extreme cases, for certain companies, they lost customer data. This has happened in 2011. So this is one concern. Second, not always online, because no entity in the world can guarantee you 100% internet access full time. So if your entire company is working from the cloud, and if something goes wrong, like connection goes down, any catastrophic uh, uh, incident takes place, either digitally or environment wise, and there is no internet access. In that case, all employees of your entire company can just stare at blank screens. Is it a possibility? Yes, it is a remote possibility, but it do exist. Mounting cost. This is a very typical example. Any company, when it shifts from the in-house IT infrastructure setup to cloud setup, it saves good sums of money, because initial cost of cloud ownership is much cheaper than the traditional on-site solution and infrastructure cost. But if your service grows exponentially, the cost also comes with that. And there's a social gaming company called Zynga. It has to move away from using the cloud-based services to the in-house setup and development, because its cloud-based cost actually started rising beyond $150 million, which is very typical example. So when I say 99%, 95% are, but there are some these examples also where the company had to move because of this mounting cost, and that too at the level of $150 million. What if the cloud provider outage? If something goes wrong, that fails because there is geo redundancy. And all these major players, Microsoft, Google, Amazon, Apple, Facebook, they have data centers spreaded across the entire globe. And there is different time zone and there is geographic redundancy also. Because of this, there are very less chances of the entire cloud provider being down or out. But if that happens, your servers be losing the computing power, the access capability. Contract woes. What if you as a company or user, you are mercy at the cloud provider's terms and conditions? Because the terms and conditions is called service level agreement. Now, what is this agreement? See, I call this agreement SLA. It's a technical document also because it has many features. It's a financial document also because based on these promising parameters, the actual cost comes and dictated between cloud service provider and cloud service consumer. It is a legal document also because if the company is not following its own promised standards, then it is a cloud consumer. You can challenge the cloud service provider or cloud provider in court also. So service level agreement is a bi-party document between cloud service provider and cloud service consumer. But in that case, if the cloud, you need 99% availability or cloud access. What if the provider only promises you 80%? Then you are stuck with the contract and you have to look for another provider, another company. And there is a very tomorrow's session, there is a very peculiar slide, there is a couple of slides where these 5 nines and 6 nines, 99% availability, 90% availability, 99.999% availability. What does it mean? That we will discuss tomorrow. Locked in the cloud, vendor locking, which we call it. So what if you develop things for cloud and then you want in-house, you want to scale back to an in-house solution? It has happened with many past players also. As a company, you develop something using Google App Engine and want to deploy that product using Microsoft Azure or some another company. What if it does not provide you that complete library support? So it's called vendor locking. And I should not give the company's name, but I'm just giving it for your understanding. It's not real cases because whether it is Amazon, whether it is Google App Engine, or whether it is Microsoft Azure, they ensure that they provide all kinds of softwares and services. They provide you all kinds of library support and database connectivity. But just to give you an example, I have given this example that you have developed your product using one PaaS platform. Will you be able to deploy the product using another PaaS platform with the same kind of database connectivity, API support? You have to cross check. And what if you develop one product using one PaaS platform and now you want to scale back to an in-house solution? What would be the cost of migrating data? What would be the cost of buying that equipment, hiring the staff? And this is locked in the cloud. So it is not only vendor locking, it is locking with cloud and then reverting back to your in-house solution or in-house capability or capacity building. Government access. Say there are new snooping and anti-privacy laws in many countries, like US Patriot Act is there, and the government level, and it is possible to access your cloud data. Now the government in question requires a warrant, but once issued, there are many cloud providers, they are powerless to do anything. Like Microsoft had some issues, so they have to move some services to different jurisdictions to avoid US government interventions. Because there are many UK based companies which are not hiring the cloud services which are US based. The reason being is US Patriot Act has different kind of legal implications. And UK or European countries have different understanding of personal privacy and security issues. And this understanding and their legal definitions sometimes do not match with the cloud service provider, which is having its data center in another country. Because many countries, many IT laws, many cyber security laws. And as a company, you have to respect all these countries' federal laws. And that's why I have given you the example of US Patriot Act. It has a different understanding of personal secrecy and privacy. But if I move to European countries, it has different understanding and levels of security, legal definitions for a person's security and privacy. And privacy is one major uh, aspect. And that's why when I say cloud, it is really difficult because sometimes a cloud company is based in one country. It has its main office in another country. It has data center spread across the globe. And if something goes wrong, the legal aspects is addressed in fourth country. And in that case, interpreting these privacy laws, security laws has its own issues. Hacking. Uh, yes, there are serious security concerns. Cloud computing is very secure, but there are examples where data is hacked and presented to the world. And let us take this infamous happening incident in which personal pictures of numerous celebrities, and some of them are Hollywood celebrities, they were leaked from the head Apple iCloud account. And it still haunts the media and the users today. So hacking and data theft is one. Second, when you adopt cloud, even for storage, even for processing, actually you are executing your computational task, your storage, and your storage processing task on a third party server. And in that case, security of your data, because it is not in your premises, it is not on your systems or your servers, it is third party servers, it is third party locations. So definitely security and hacking is a major threat. And while making or drafting the service level agreement, as a company, you have to take care. And if you are an individual cloud user, you have to also go through the entire service level agreement very carefully. Online help desk. You can cut down in-house IT and technical staff. It looks good, cost cutting, you are saving a lot of money. So you feel very happy because it is handled very well. And the cloud service providers also have the best of the technology solutions. But sometimes you need to have your own technical staff on the ground, which is great help rather than phoning to the person. Uh, Change is not always good. There are certain cloud-based solutions and alternatives to that. So basically what you try to address is you just try to take the sneak preview of front-end web pages, portals, other elements in constant use. But it can be damaging because people do tend to fear significant change in technology, like moving from Windows 7 to Windows 8.1 or different Office versions. And you have to also see that these technical issues can be very costly in terms of time and expertise. So change management is one major area, not only of management, but technology management, which you need to address if you are a cloud consultant and you are advising some company or enterprise to move from in-house solutions to cloud solutions. You have to pay enough attention to address this change management, human perspective, technology perspective, as well as financial perspective. If we have addressed issues with cloud, there are other aspects of why cloud, why I have to adopt cloud, why do we adopt cloud computing solutions rather than having my own in-house IT setup, which is a traditional setup. So let us see some certain promising sides of this cloud paradigm. Number one, flexibility. Cloud-based solutions are incredibly flexible in their design. They can grow as your business needs increase and they can scale back. So basically, what I want to convey to you is it's not only scaling up and scaling down. It's more of services. So these cloud-based products are rendered to you as an end user in form of services, and they strictly follow service-oriented architecture. And when they follow service-oriented architecture, they are loosely coupled. And when they are loosely coupled, they help you to develop RIA, rich internet applications. And these rich internet applications can create this flexibility environment. And this flexibility environment, because of this, if you are a banking company, rolling out banking solutions is very agile. If you are a security company or a manufacturing company, adopting robust cloud services is very feasible. So when you are operating at this level of operational agility and elasticity, the cloud solution is perfect for business model and consumer IT model. So one prominent benefit of adopting cloud computing or cloud services is flexibility. Automated updates. Even though we have discussed a one bad incident with Amazon in 2011, you can update your server in a time consuming and competitively stressful affair. That's what your in-house setup is. But when you are adopted the cloud solution, attaching relevant security patch is cakewalk because they have their own engineers and their staff. There is no stress. Everything is in place. They keep the patch and related technology aspects in place, and they make these automated updates in a very seamless fashion. And that's why if it is in-house, updating a server or updating one particular application requires a lot of time, energy, effort, and stress. But updating a cloud-based server or cloud-based applications or services is really cakewalk because of the technological advancements and economies of scale at the service providers end. Disaster recovery. If you are in business of any size, whether you are home user, you should be concerned with building a robust disaster recovery solution. Because if there is a localized catastrophe, you lost your personal files or critical business data, and it's a nightmare kind of situation. But all these major cloud service providers and cloud solution providers, they have data centers spread across the entire globe. They have very strict redundancy policies, and because of this, if something goes wrong, either technically or catastrophic environment kind of situation, in that case also, your data can be recovered very quickly, and it is almost user transparent. Because friends, I need to highlight here, you never know whether your data is there in Bangkok data center or it is there in Mumbai data center, or there are multiple copies. If I talk about Amazon, they create region-wise availability zones, and these availability zones have a very strict, stringent data storing philosophy and practices which they practice or which they implement very rigorously. And because of this, disaster recovery in cloud is very easy, and there are no chances of losing your personal data or your critical business data. So disaster recovery, flexibility, these are good points to consider cloud. We already discussed capital expenditure and operational expenditure. So if you want your business to grow, it's a pay as you go model. And I already discussed that the entire uh, investment of one bank when they move to the cloud reduced to 20%. For security reasons, I cannot name that bank, but 20%. Now, can you imagine if you are as a chief technology officer, if you are investing $2 billion every year for IT procurement or IT infrastructure procurement and staff and softwares and licensing cost and all this, moving to cloud is really very beneficial. Second, cloud gives you elasticity also. So flexibility and elasticity are two parameters that we will discuss tomorrow in greater detail. But this elasticity, scale up, scale down, because of this, you can reduce the cost. Collaboration. Inherently, cloud supports collaborative environment. It means co-workers can gain access of company's data as a single unit. So there are no multiple documents of one project. Even if one technical project, all the team members can collaboratively work on that cloud project application software. And because of this, data updates are real time and workflow is also less confusing. And whether it is a project, whether it is a collaborative document or application or presentation, cloud is the best launch vehicle for collaboration. Security. There are a couple of incidents of cloud hacking, but keeping data in the cloud is regarded as being far more secure than having them on your local, because there are incidents of lost laptops, USB flash drives, hard drives recovering, hard drives getting burned because of the temperature part, or there are certain companies which follow or adopt the uh, bring your own device concept. So bringing your own device, there are security issues. So if you want to address all these security issues, whether they are local ones, whether they are technical ones, cloud gives you a very good security, like platform as a service or desktop as a service. So when you say desktop as a service or storage as a service, the storage as a service or desktop as a service actually addresses all these company related issues like lost laptops, flash drive issues, hard drives getting corrupted or infected. All this can be addressed very easily. So security point of view, cloud still has an upper edge with in-house kind of solution. Access from anywhere. As long as you are an employee or an individual, and as long as you have the internet connections, you can access to your cloud data, applications, services, softwares. It is ubiquitous in nature. Competitiveness. If you want to give competitive edge to your company, then cloud is the best solution. Because when you use cloud model to run your business, you can significantly improve your competitiveness in the market. Not only that, you have access 24/7 to the servers, to the cutting edge applications. Because when you adapt, let me give you the example, like if you adapt salesforce.com, it gives you that cutting edge advantage because you are using one of the finest ERP CRM solution in the world, and you are giving that ERP CRM solution benefits not only to your employees, to your business partners, to your clients, to your business associates also. And this competitive advantage can help you to put more value addition to your uh, corporate existence. Document control. You can have numerous users all working in one single document. Collaborative approach, if it is not there, there are conflicting copies, there are many formats, there are some templates with older versions, multiple copies are there in email. So there are digital storage costs also, because the very same documents are copied many times, emailed many times to the project partners or business associates. In that case, if you just want to reduce down, you have to gather the document control. And cloud computing or cloud solution is one very good way to keep one digital copy in collaborative platform, which is accessed by all associates, all our project partners, and can also save the sending multiple document email to many times. So this is how you can also reduce your carbon footprint. So document control is also one good way. And as I have told about carbon footprint, the data centers that house cloud services are vast, energy hungry places. And if I say globally, 3.5 to 4% of the entire global energy consumption is only these data centers. But 3.5 to 4% seems very high number. But think about them as individual servers. Perhaps they would be consuming far greater energy sources than the data center solutions. So these data centers, even though they are energy hungry places, they still saves a lot of computing resources for which you pay. And this is the biggest benefit of cloud, that the overall energy required by the data center is as minimal as possible. Second, it is economies of scale also. So when it is carbon footprint, that economies of scale actually is a tricky part, and that actually makes the magic. You can save a lot of energy in not only in terms of electricity, but also you can adopt renewable energy options like Facebook, Google, and everybody is adopting. They have set up wind farms, solar energy, and all this. So there is no wasted power makers for a green carbon footprint than a traditional server room setup, because traditional server room setup is far costly, not only in terms of money, but also in terms of carbon footprint. So what are the basic consumer services that we have? Will go a bit fast. There are many like storage. So storage is one which is dominant consumer service, and it is one significant also. Dropbox, Google, Microsoft, Apple, they all offer this. Now, the second one is music streaming. Now, this is where I said that cloud computing is a revolutionary concept. It is not only evolutionary. The reason being is it has changed the way we listen to music. And Spotify or iTunes, they are billion-dollar companies. iTunes itself gives roughly more than $6 billion profit to a company called Apple. So thanks to these cloud services, you don't have to physically own the music. Your devices also got changed. You don't buy Walkmans no longer. There are no longer your mobile phones. Through your mobile, you can adapt to any kind of using streaming services. And it gives you far more musical choices to any device that can be owned. So it is more of a service-based delivery model. So music streaming is a very good example of cloud's service-based delivery model. And there is an entire setup of iTunes or Spotify or other such applications and services which are there in market, and they give you far better solutions in the music industry. Email access is the second biggest consumer cloud service, that is email, and it has also seen a very big this. And because browser is a sandbox environment, through these emails are one very big success stories. You can, if I give you one case study, because so far in these presentations we have not discussed a case study. So let me give you a case study. Just look at the revenue model and the success story of Google before they launched Gmail, and just observed the success story after they launch Gmail. Mapping and GPS. If you are looking for a new house, you will definitely visit Google Map or Bing Map or Apple Map. GPS for locations, GPS for new property, GPS for settling down is a very big example of cloud consumer services. Social media. We are familiar with social networking sites and people uploading millions of photographs. And if I say internet minute like 300 hours of video is uploaded on YouTube every 60 seconds. There are 7 lakh people who are attending any online meeting of these so major platforms every 60 seconds. So there are almost 700 million plus photographs. They are uploaded on Facebook every single day. There are 3.5 gigabit of internet traffic which YouTube observes every day. So social media is a very big example of the cloud success story and cloud consumer applications. Remote access. See, there is the example of TeamViewer, and there are many companies who are actually using this TeamViewer and other such cloud-based applications through which this remote access is not only materialized, but it is actually giving value addition. You can access your desktop. It gives you business sense also. It makes business sense. It makes seamless access a reality. And remote access is one major cloud success story use case. Video streaming, Netflix, Amazon Prime, they are very famous, popular video streaming examples. In fact, in 2005, Netflix shut down its last data center and now they have adopted 100% cloud-based structure. They are completely on Amazon Web Services. They have adopted this AWS. Anonymity. There are many countries also where some of the internet uh, services or cloud services are not available. So virtual private network as a service is a popular platform, and there are many cloud-based services. They are used to hide users' IP addresses. There are gray sides to it, but there are many countries in which virtual private network is a blessing through which they can access some of the finest cloud consumer services. And they can also gain access to content or cloud content in these countries. And this anonymity sometimes is a bliss to some of the researchers or technology people. Gaming we already discussed. Yes, this is one major consumer service market, and it is a very fast growing market for cloud. It's a multi-billion-dollar industry also, and there are many companies which are having very strategic investment to have the larger pie of this billion-dollar or multi-billion-dollar market. Printing is one cloud consumer service where you can print from anywhere on any device, and there are many users of this cloud consumer services. There are top cloud storage providers like Google Drive, Dropbox, and iCloud, and we'll just briefly discuss them. Google Drive was launched in April 2012, and it is one of the longest running cloud storage solutions. When it was launched, it was 5 GB. Later on, all cloud, it is Google Email, Google Drive, and Google Photos combinedly 15 GB. So 15 GB to 30 plus terabytes. That's a very big, huge number. So when it got launched, overnight success 2018, Google announced that the drive had stored over 2 trillion files, and then it has already crossed 10 trillion files milestone in later part. When it was launched, it was Google Drive gave 5 GB of free storage, and it was one major uh, storage solution or cloud storage solution than its competitors. But later on, all followed this, and now it has given 15 GB of free storage solution. That is, Google provides this. But here in this slide, that is not important. This Google storage service matured, and Google Drive offered users unlimited number of photos at a maximum of 16 megapixels, videos with a maximum resolution of 1080 frames per second for free, and using high quality setting in Google Photos, which is shared space from Google Drive and Gmail. So Google Photos, Google Drive and Gmail combinedly 15 GB. But that is not more important. Here the point is 16 megapixel. Here the point is resolution of 1080p. That is something which is original quality setting. And all the competitors actually followed it. And that's why when I conclude, I can say that Google Drive is one very big cloud storage service solution to the entire digital fraternity. It gives internet presence. Huge geolocation servers are there, and the server farms gives you capacities, massive user base, and continuous improvement. And that's why Google Drive is on the top consumer cloud option. Another one is MediaFire. It was launched in 2006. It is Texas based, and it has now, this is because all 250 million plus user base. And this is how it looks like. But here you can see that it gives you four major cloud verticals: store, access, collaborate, and share. So MediaFile, when they offered, it was 10 GB free plan. And then we can upgrade to the amount of free storage of 50 GB. Then the company started giving you the desktop client version. So you can upload, sync, download, and so on. But later on, the mobile app was also launched. And when the mobile app of MediaFire was launched, automatically upload, backup, photos, videos to this MediaFire server, the facility was given. And then from 10 GB, like if you want to adopt a pro option of 1 TB or 100 TB, it is also available. So any company which is very large in size in terms of storage requirement, they can adapt to this solution. So if I conclude the MediaFile, my discussion, it is feature rich capability, that of level of Google Drive. And what are the bad points? Now let us discuss them. Mediocre collaboration option, built-in office suite, desktop client, and limited sharing capability. Even though they were there, it is a good free version option to many users. Now I give you a better example, and this is a use case. So let us discuss this use case of Dropbox. It is headquartered in San Francisco. It was formed in 2007 by MIT students Drew Houston and Aras Ferdowsi, and it has seen many changes in this time. It is now valued at more than 10 billion or $15 billion, and it has a user base of almost 700 million users, because this is, as I said, bit old slide. It is one of the best top cloud storage services in the world. It is said that 2.2 billion files are uploaded to Dropbox daily, which is probably why it is considered one of the best cloud storage solutions available today. The problems with Dropbox: lack of security, because we have witnessed many high-level breaches in the past, and it does not employ a zero knowledge policy, and it's not most privacy friendly also. It is blocked in China since 2014. It's not the cheapest or the best cloud service available, but still, why people use it? Because people use it, Dropbox, because it's ease of use. Many of its users feel quite at home with both the web interface or version or the desktop app version. And they also launched their mobile app. So when I say Dropbox prices, the prices are 2 GB is free storage, and then you can upgrade to 2 TB for certain cost. And this is the cost slide. So let me just keep them. Dropbox files is in the main storage area where you can use them as individual or as a company. The only thing you have to do is you have to drop them, all files or folders. So you can just drop them. In 2017, they actually withdraw the ability to drag and drop feature, the entire folder in its web interface. But later on, they actually uh, 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 relaunch this feature. You can drag and drop the files from your computer into the newly created folder. And so far as folders are concerned, you can drag and drop this folder one at a time. So that is the limitation. So you only one folder at a time. And this feature was relaunched in 2018. So here I can conclude that despite of many drawbacks of Dropbox, it is one of the best services you can get, and you can collaborate here. OneDrive is Microsoft's cloud storage solution. It was launched in 2007, and then later on it was renamed. The best part of OneDrive is nothing but the way it integrates with its Office 365 solution. That is the best. It is very feature rich, and this feature rich actually makes it one very good because it can incorporate with the entire Office 365 suite of apps and services. And this integration and the way they give you this free user space of 10 GB of storage and all this is actually a good solution. Anyway, I'm just skipping some of the slides. Here also the slides says about integration with Office 365. You have to just right click Word, Excel, PowerPoint, OneNote, they all are integrated, and this is one good solution. Pricing, I don't want to spend much time on this slide, and I conclude that it is still one good storage solution. Now, why I have taken this storage, OneDrive, MediaFire, all this, because cloud storage is one very major success story to make cloud a $1 trillion industry. iCloud got launched in 2011, and this is the normal screen of iCloud. And this is the pricing part of iCloud. I just concluded. There are various cloud platforms. Amazon Drive is there. I'm just skipping this because more or less they say the same story. How much free storage is there? What are the main features? Drag and drop, desktop version, web interface, success story and all. Let us go to the last part of my presentation before I move to this. So Google Cloud. So there are many Google Cloud apps, but because we are running short of time, I'll just read them because we are using them day in and day out, like Gmail, Drive, Google Docs, which is one very good collaborative platform for editing, writing, and collaborative on any product or project, Sheets, calendar, sites, handouts, and all this. Now I come to the last part, and this is intentionally kept in the last because I always believe that virtualization is the technology which drives the entire cloud success story. Now, what is virtualization? So generally our setup is we have bare metal hardware, which we call the system hardware. Over the system hardware, conventionally we have operating system, and over the operating system we have applications. This is the normal setup. Now what we do is above the bare metal hardware, we insert this abstraction layer called hypervisor. You can also call them virtual machine monitor. Now this hypervisor actually makes it type 1 virtualization. So you have bare metal hardware, then virtualization layer, and this virtualization layer, then after the operating system, which we call guest operating system. This is type 1 hypervisor. There is type 2 hypervisor also. What is type 2 hypervisor? What you have is bare metal hardware. Above it, your conventional host operating system. And above the host operating system, there is a virtualization layer, which we call hypervisor or virtual machine monitor. And above this virtual machine monitor, you have guest operating system. So there is host operating system, then there is virtualization layer, and then there is guest operating system. It is called type 2 hypervisor. So type 1 hypervisor is full virtualization, and type 2 hypervisor is partial virtualization. So with this basic understanding, let us go to server virtualization. So what is server virtualization? This full virtualization that we implement is called server virtualization. And on this server virtualization, we can have all our cloud services rolled out. So we call it system virtual machine. So virtual machine which we create is called system virtual machine. Now what is system virtual machine? That is server virtualization. And it is used by infrastructure as a service provider. And that's why we call them server virtualization, which is here on your screen. Another type of virtualization, because this is the traditional architecture, bare metal hardware, then operating system, and then applications. And I insert the virtualization layer, which I call VMM, virtual machine monitor. And this is virtual. So this is server virtualization. It's called system virtual machine. Platform as a service people, they use process virtual machine. And this process virtual machine is nothing but it's a pre-setup of providing the development environment or integrated development environment. Anyway, so now you are very clear. System virtual machine and that virtual machine. Anyway, so we already discussed type 1 hypervisor and type 2 hypervisor. And this is the privilege level of this virtualization setup. This is my last slide in which I discuss about live migration, because these are virtual machines and this pool of virtual machines, when we implement them, this pool of virtual machines because create a pool and it can be lively migrated from one physical rack server to another physical rack server. And it's called live migration. And because they are virtual entities, they can be lively migrated. So if anything goes wrong with the physical machine, all the virtual machines can be lively migrated from one hypervisor setup to another hypervisor setup. And that is the secret source behind the success of cloud. I think we have only 4 minutes left, so we don't have much time to run the shall we open the chat part? So what is the most important concern of cloud computing? Yes, the most important concern of cloud computing is nothing but the security. People say outage, but I personally feel the security, the hacking part, because that is where you lose the customer trust in you if you are a cloud service provider. How many parts we can broadly divide the architecture of the cloud? Now, yes, the architecture of cloud has many understanding, but if I say deployment models, there are private cloud, public cloud, community cloud, and hybrid cloud. If I say service models, IaaS, PaaS, and SaaS, so these are some of the architectural understanding of cloud. But if I just say the actual architecture of the cloud, then I will say the data center architecture, because it is the actual architecture of this data center. So when I say architecture of the cloud, I have to say the architecture of data center. And when I say architecture of data center, I can divide them into this many pillars, like you have rack servers, you have rack storage, you have gigabit Ethernet, and you have got the energy part, that is cooling and all this. So I hope I have addressed your concern. So conventionally, we say deployment models, we say service models, but when I say architecture, for me, it is data center architecture in which we actually implement the cloud solutions, or rather cloud technology solutions, because cloud solutions can lead you towards applications and services. But when I say cloud technology solutions, it is the data center where I have gigabit Ethernet, I have rack storage, I have rack servers, I have top-up rack switches also, because 80% of my data center traffic is the internal traffic, and that's why I have a terabit Ethernet or multi-gigabit Ethernet in my data center. Cloud is very economy, but still many government offices may not using. Why? Sir, I would like to brief you here that majority of our government services, it's not only the example of DigiLocker or Aadhaar card, they are cloud-based solutions. Even you say GS1, Gujarat State Wide Area Network. So Gujarat State Wide Area Network is nothing but it's one cloud solutions where these collectorate video conferencing and all this storage and all this actually. If I say India level example, NIC, NIC one company which is having majority of its IT solutions and IT platforms on cloud base. What is cost of clouds? Which service provider provides cheap service? Yes, as a Gujarati, we are very much interested in financial aspects. So I really value your question, but my answer to you is fragmented one. It is the service which you want to adopt, because if you are interested in storage, there are many providers and they have different financial uh, grades. If it is the software as a service, again in your segment you can have multiple service providers, but any company which is giving you low cost solution, which has no security addressing in service level agreement, you should not consider. So when I say economy, I have to consider, when I say economy, I have to consider what level of service level agreement they offer, like fault tolerance, availability. If they are offering 90% availability and they are very cheap in terms of infrastructure as a service or platform as a service, I should not adopt. Rather, I should go for little bit costlier 99.99% availability, because 90% availability matlab 36.5 days they can be down, but 99% availability matlab 3.65 days they are down. So from 36 days down commitment to 3.65 days down commitment. And if it is 99.999, then it is few hours down entire year. So when I say cost to cloud, we should consider this, that fault tolerance, availability, and other monitoring features the cloud service provider which gives it to me. Which cloud service in market other than AWS? Okay. Yes, Microsoft Azure, Google App Engine, they are some of the past years solutions. Other than that, if you are in enterprise like CRM and this, then we have Salesforce.com, where Force.com is a PaaS solution and Salesforce.com is a SaaS solution. So yes, there are all major companies, Microsoft, Google, they provide cloud solutions and in all verticals, whether it is IaaS, PaaS or SaaS. Into which expenditure does cloud computing shifts capital expenditure? Uh, Sir, as a company, your capital expenditure is nothing but upfront investment. That means buying servers, storage, uh, softwares, license cost, IT staff maintenance cost, upgradation cost. So this is all. Uh, and when I say upgrades, maintenance, they are nothing but they are operational expenditure. Now, when it is cloud way, in that cloud also, one thing is very peculiar, and that is nothing but you are not shifting your uh, capital expenditure. Capital expenditure is borne by cloud service provider. But cloud service provider, for him, why he is making? Because economies of scale. If I'm making 5,000 bottles, it is maybe 13 rupees per bottle cost. But if I'm making 50,000 bottles, the same quality bottle or perhaps higher quality bottle would be 6 rupees per bottle. Economies of scale, this is the example. So any cloud service provider has to make that millions of dollars of capacity building and expenditure in terms of procuring direct server storage and all this. But for him, economies of scale, and second, because of virtualization, he is saving lots of money because almost 85% plus server utilization, 90% plus storage utilization. And that's where they actually save money. And this benefit is given to back to the customer in terms of uh, uh, cost. In cloud computing, the client is on which end? In cloud, the client is a cloud service consumer. So you are there is a cloud service provider and you are cloud service consumer. But if you are using public cloud, then it is third party hosted services and it is provisioned to you. So you are basically consumer and you are no longer client because there is no notion of product. It's more of a service or service consumer. So you are a consumer, whether it is IaaS or PaaS or SaaS. The most important concern of cloud, as I said, it's security, hacking. How many parts can broadly divide? Okay, I already answered this. On what is cloud computing based? Cloud computing is based on certain technologies. One is development in storage and processor technology, multi-core architecture, and very cost-effective storage solution. That is number one. Number two, service-oriented architecture and web services. Number three, HTML5 and advancements in internet technologies. And number four, it is the softwares, the development environments. Because if cloud is an enabler technology for blockchain, as I said, for IoT, for data analytics, I can say that multi-core architecture, storage solution, number one, service-oriented architecture, number two, programming and development environment, number three, all these are enabler technology for cloud. So cloud is based on these enabler technologies. Where India government and industry, private, stands in cloud service providing globally. Fine, very good question. Uh, let me take a very pragmatic view on this question. As a country, we have our own setup like NIC. We have our own company setup like uh, uh, other setup where military is using some of the cloud-based solutions and all this. So far as industry is concerned, we are not the global majors. We do not own Google or Microsoft or Apple or say Facebook. But yes, Indian companies have their own data centers and they have private clouds which are serving their requirements. Indian companies, all Indian majors, all Indian major business houses, they have their own this. They also because they use hybrid cloud. So some of their solutions are uh, company-based cloud deployment, and some of their solutions and services are they are using third party like Google and Amazon and all this. But yes, so far as federal government is concerned, so far as state government is concerned, Aadhaar, UADAI, uh, all this, they are even NIC, statewide area networks. So these are strategic investment government of India has made, and it is actually very much security aspects also, because when I need my citizens' data, I have to ensure that this is used by federal governments. So there are many government offices, there are many federal governments, they are using them. And I should not say they are baby steps. They are mature in terms of not only deploying these services to the citizens of India, we as proud Indians, but slowly and steadily, even people of India has also adopted all these solutions, whether it is DigiLocker, whether it is this, and universities and research organizations also. Like if I talk about GTU, so all mark sheets are cloud based. All major operations of GTU are using third party cloud solutions. So it is very much there. I think we are almost done with all questions. So thank you for your patient listening. I know I was some of these slides were very text rich, but I just try to make it as lucid as possible. One more time, I thank the organizers and all the attendees, because without you it was not possible. So thank you very much. See you tomorrow. Tomorrow we would have another session on cloud computing, which will be more technology rich, and it will discuss all aspects of technology and engineering with respect to deployment models and service models. So see you tomorrow. Thank you very much.
Thank you. Thank you very much, Dr. Chirag Thaker sir, and the all participants. We'll again meet with the same sequence and same advanced version of clouds and the technological parts. We'll meet again on tomorrow, same time, same platform. Thank you.